The mic is on, yeah. So welcome to my talk on WebAssembly. My name is Steven. I'm a lecturer at the Hoogent University of Applied Sciences that Sebastian mentioned earlier this morning. I don't get to do a lot of Swift in my day job, but I try to be an active community member. And most importantly, I try to get my students involved in the Swift community. So you saw a little bit of that earlier this morning in Sebastian's talk, and you will see a little bit more this afternoon. I'm not a developer, but I do try to contribute when I can find some time. I did some of the initial work on the Swift extension for VS Code because we really need that in education. I worked on improved Swift support for Highlight.js, which you may know from the Swift UI tutorials, and various other smaller stuff. But most of my free time goes into maintaining this platform, which is the PWS Academy. It just stands for Programming with Swift because I'm not creative. Couldn't find a better name. So I just wanted a meaningless acronym that has pretty much no meaning. But this is where I gather most of the stuff that I do with Swift in education. And my primary goal here is just to develop hopefully high quality computer science courses and make them available for free, which is especially important if students live in a country where they don't have access to affordable higher education like what we have in Belgium. But as a secondary goal, I'm also trying to introduce Swift as a teaching language in higher education. So to replace the languages like Java or Python or C# that we're using today. Swift has a lot of amazing features that make it really suitable as a teaching language. But yeah, unfortunately, its biggest pain point is often cross-platform support. But it's doable. So we have one course ready, which is the fundamentals course. It's quite unique in that it's a programming 101 type course, but it uses Swift, and it supports Windows, Linux, and of course, Mac OS. So this proves that it's possible to teach Swift on Windows, but still cross-platform support is not yet where it should be. So ever since Swift was open sourced, I've been closely following all of the efforts to bring Swift to new platforms, to open up new use cases. And this talk is about one of those efforts, which is the SwiftWasm project. So SwiftWasm is abbreviation for WebAssembly. I've been spending a lot of time with this over the past year. So this talk is me sharing what I learned about WebAssembly. I'll do my best to explain what WebAssembly is and what it means for you lot Swift developers. So what is WebAssembly? Well, WebAssembly describes itself as a binary instruction format for a stack-based virtual machine, designed as a portable compilation target for programming languages deploying on the web, and they also mention a client and server applications. Now, the key phrase here is that it's a portable compilation target. So WebAssembly offers a lightweight and memory-safe sandbox execution environment, basically a virtual machine, in which we can run code compiled from any supported languages like C, C#, Rust, but also Swift. All you need is a WebAssembly runtime. But fortunately, these runtimes are available anywhere, not just in a browser. So what does WebAssembly offer for Swift developers? Well, the most obvious thing is that it lets you run Swift code in a browser. Now, this doesn't mean that you can just take any app, like a Swift UI app, compile it to WebAssembly, and run it in your browser. Obviously, it's not that simple. But if you design your app in such a way that most of your domain code can be in a shared library, independent from any platform-specific stuff, then you should be able to reuse all of that code to build a web app. A nice example here is GoodNotes, which you may be familiar with. It's a popular note-taking app for iPad. GoodNotes used WebAssembly to build their web app. So they were able to reuse, I think, about 100,000 lines of Swift code from their iPad app, combine it with React for the UI stuff, and build a web app. If you want to know more about how and why they did it, they gave a talk at NS Spain last year. So go check this link if you want to know more. Another use case I found is that WebAssembly lets you run Swift on the server. Obviously, at this conference, I don't need to mention that Swift already runs on the server and that we have plenty of frameworks and libraries to support Swift on the server. But WebAssembly claims that it still has something to offer here. As I mentioned before, they offer a lightweight, memory-safe, sandboxed execution environment. And compared to Docker containers, which I assume is what most of you use, WebAssembly may have something to offer in that it's more lightweight than a complete Docker container. So especially for stuff like serverless functions, where a small binary size and fast loading times are really important, it could have some benefits. An example of this is Swift Cloud. That's a platform where you can write your serverless functions in Swift, compile it to WebAssembly, and then they deploy it on, I think, Fastly Compute. Andrew gave a talk about this on the previous ServerSide.swift conference, and this is one of the videos that's actually already online, so you can just watch the video from the previous conference. So not all videos are not yet online. And then a more recent use case I found, I didn't even imagine this when I started looking at WebAssembly, is that it lets you build a plugin system. So for example, this proposal describes how we can use WebAssembly to build Swift macros and load them as plugins, mostly to reduce the build times that are associated with macros. Of course, loading WebAssembly modules into a Swift app, that also requires that we have a WebAssembly runtime written in Swift and that we can integrate into our apps. But fortunately, such a runtime already exists. And I'm going to mention it very shortly. So all the use cases I mentioned, they're all made possible by the SwiftWasm project. I'm not affiliated with this project in any way, so I'm just speaking my mind. But I'm happy to support all the work they've been doing to bring WebAssembly support to Swift. So what do they offer? Well, the first is a SwiftWasm toolchain, which adds support for the WebAssembly target to Swift. It lets you compile Swift to WebAssembly. Now, most of the changes that are in this toolchain are already upstream. So the upstream toolchain already has some support for WebAssembly. But if you want all of the features, for now, you still need to use the WebAssembly-specific toolchain from SwiftWasm. SwiftWasm also provides Carton, which is a package manager plugin that lets you very easily build web apps with Swift. And of course, if you're going to be building web apps, you also need to interact with JavaScript, unfortunately, sooner or later, sooner rather than later. But that's what JavaScript Kit is for. So that's a framework that lets you interoperate between JavaScript and Swift. And then finally, SwiftWasm also provides WasmKit, which is the runtime I mentioned before, runtime written in Swift that you can integrate into your Swift apps. So that's my introduction. So I hope by now you're all excited to learn about WebAssembly and you want to see some demos. And I brought enough, so we can have some fun. All of the demos that I'm going to show are on GitHub, and I did my best to document them because that's most of my job is writing documentation for my students. So if you want to try them out, just wait until the end, and there's a link at the end to the GitHub repository. So let's get started. Yeah. The first one is pretty basic. Oh, the screen is so big. It's all the way over there. Yeah. So for me, the most basic example is not just hello world. That's kind of boring. So if you're doing WebAssembly, the most basic example is just render something on a web page. Use Swift to somehow manipulate the DOM and put something on a website. So the easiest way to do that is to use the Carton plugin that I mentioned earlier, which is a Swift package manager plugin. So you just add it here as a dependency to your package. You also need JavaScript to interact with the DOM, so we also add JavaScript Kit as a dependency. And then in main.swift, you can just use JavaScript Kit to create a paragraph element, put in some text, and append it as a child element of the body element. So it looks easy. It is quite easy, but you have to keep in mind that JavaScript is a dynamic language, and JavaScript Kit relies really heavily on, you can see it here or there, dynamic member lookup. So JavaScript Kit provides a global object, JSObject.global, which corresponds with the window object that you may be familiar with if you've done any development in JavaScript. But most of the other stuff is just dynamic member lookup. So this document property, this create element method, inner text property, the body property, append child method, it's all dynamic member lookup. So there's no static typing, there's no auto-completion, so it can be a little bit tricky. And keep your MDN on the side so you can look up the correct names for all of the different APIs in JavaScript. The return value of all of these things is usually a JS value, which you can see over there, which is just a simple enum that enumerates all of the different types in JavaScript. Usually you can just keep using dynamic member lookup on your return values to go to the next method or property that you want to access. But you may need to do some conversions between the JS values and the Swift values. But it still looks fairly easy and fairly close to the JavaScript that you're trying to write in Swift. So how do you build this? Well, if you're using Carton, you can just run the plugin with Swift run Carton, and then the def subcommand is a debug build. And I've also added a custom HTML page, because I assume usually you don't want to start from a blank page. So we can also specify that we want a custom index page, which is web index. And then Carton is going to do pretty much everything else. So what is it doing? Well, first it's checking. Oh, it's going way too fast. I'm trying to explain. Yeah, I pre-compiled all of this because I gave this similar talk last time, and then you have to just watch me build stuff, which is quite boring. So first, Carton will check Swift version, a .swift-version file. This just specifies which version of the WASM toolchain that you want to use. So I'm just using a daily build from September 7. I didn't want to risk updating just before the conference. And then Carton will check if you have the toolchain installed. If you don't have it, it will install it for you, which is really nice. It's just quite large, so you have to wait a little bit. Carton will use this toolchain to build your app. It will generate a WebAssembly module. It will generate lots of JavaScript boilerplate code to load the module. It will bundle your HTML page with the JavaScript and the module. It will spin up a web server, deploy it to the web server, and here you have the result. So that's the most basic thing that you can probably do with WebAssembly. Now, Carton makes this really easy. In fact, if you're trying to learn about how all of this works, it's a little bit too easy. So when I finished this, I still had a lot of remaining questions. For example, I don't want to build my entire app in JavaScript kit. How can I integrate some Swift stuff into an existing app? Or what if I'm not even trying to build a web app? We just saw that WebAssembly can be used for other stuff. So what if I don't want to run it in a browser? How can I just build this with the Swift compiler without the help of Carton? And how can I integrate this into whatever app that we may already have? So that is a topic of the next demo. Next demo. So here the idea is, let's just take a step back. Let's just build a simple Swift package that has no dependencies and just does something that's a little bit less trivial than Hello World. In this case, I just print the command line arguments and environment variables passed into the module, just so we can check if it's working. So to build this without the help of Carton, it's not that hard. You just run Swift build. Just keep in mind the Swift executable has to come from a SwiftWasm toolchain, not a toolchain that comes with Xcode. This doesn't support this specific WebAssembly target. Then you pass in the target triple. So in this case, we're compiling for WebAssembly with WASI, which is something that we'll get to in a moment. And we have to specify static linking for the standard library. So this one line is enough to compile this package into a WebAssembly module. And this module should be in my Swift package, the build directory, WebAssembly target, debug build, and I think I named it command. .wasm. Yeah, it's there. So we can actually already run this. We don't need to build a web app first. As I mentioned, you can run WebAssembly anywhere that you have a WebAssembly runtime. In this case, I've installed the command line runtime wasmer, and I will wasmer run this module. It's really hard to type on a keyboard like this. It's good I didn't do a live demo. Command.wasm, voilà. And then we should just see that it prints. Command was executed with one argument, which is the name of the module, and no other arguments and no environment variables. So that's a nice way just to test if your module is actually working. Now, what I like about Wasmer is that it has an inspect subcommand. So if we run that, we can learn a bit more about what's inside the WebAssembly module. So inspect will show us, first of all, that the module is way too large, 60 megabytes. But most importantly, that it has a bunch of imported functions and exported functions. Modules are quite simple. They provide functionality through exports, and they depend on functionality through imports. If you just build your module the way I did it, you just get the standard exported start function, underscore start, which just runs your top-level code, whether it be a main.swift or at main function, just your main code. But you can also see that there are a bunch of imports. And they're all prefixed with the same prefix, which is WASI underscore snapshot underscore preview1. I was a bit confused when I first saw this because you also have to do a lot of other stuff with the same name. But these functions are the WASI system interface. So WebAssembly system interface, or WASI. If you know POSIX, it's kind of like a lightweight POSIX for WebAssembly. So these functions are how WebAssembly modules can interact with their host environment. So our module declares these as imports, so we do need to provide an implementation for all of these when you want to load the module in a web app, which is what I need to show next. So this was our Swift package. As you can see, my examples all have the same structure. There's a Swift app, there's a web app, and there's a build script. So if you get them from GitHub, you can just run the build script, and it should hopefully just work. The web app, if you've done any web development, this should be really familiar to you. It's just an NPM package, and it uses Webpack to build everything and just generate one output file. So here in index.js, what we have to do is we have to first load a WASI runtime. This is micro WASI. You can use whatever runtime you want as long as it's compatible. I'm just using micro WASI because it's also provided by SwiftWasm, so I'm just trying out all of their different projects. So I just instantiate a runtime. I just set some arguments, environment variables, just to test if our module is working. Then we can instantiate the module, and then we have to provide a very special object here, which is known as the import object. So this object is responsible for providing implementations for all of the imported functions that you just saw. So we can see the imports are prefixed with WASI underscore snapshot underscore preview1. So we must have a property here with exactly the same name, containing all of these functions that you see here, argset, argsizes, get, and so on. But fortunately, these are provided by the runtime, so we can just hook it up here. Just make sure that this property is spelled correctly. Yeah. So once we have the instance, we can start it because we can just ask the runtime to start the instance, and this will just run your code in underscore start, or just your top-level main.swift code, top to bottom. So if I run the build script, it shouldn't take too long because I pre-compiled it all. And then we should see the index.html page that I made, and then the output showing the environment variables and arguments should be here in the console. So all the stuff that we print in Swift just gets mapped to the console in JavaScript. So that's how we can build a Swift package, compile it to WebAssembly, and then load the module in an existing web app, all without the help of Carton. Of course, we're not done yet, because what we just built here, we just close this. what we just built here is known as a WebAssembly command, which is kind of like an executable. You load the module, you start it, it runs top to bottom, it finishes, and that's it. Usually what you want is more like a library where you can declare a number of functions and you can just call the functions whenever you need them over and over again. In WebAssembly, this is called a reactor. So we have the command and the reactor. It's quite similar. Let me run it first so you can see what it does. So I have the same structure as Swift app, web app, and a build script. So this is just a simple example. I just have one button, and whenever I click it, it generates a random die roll and just shows appropriate image. I just reused one of my school examples just to have something that's not hello world. So the idea is that we have a function that we can call multiple times and not just a single use executable. So how do we build this? Well, in the Swift app, nothing fancy. You just generate a random number. Use JavaScript kit to get the appropriate image element by ID in this case. We have to set its source. So the source attribute of the image element is just mapped as a source property of this object, and set its style to make it visible because it's hidden by default. So another simple example that uses JavaScript kit to interact with the DOM. To build this, as a reactor instead of a command, you do need some additional command line flags. So these are the same as for building a command. But to build a reactor, you need to specify that you want to link it using the reactor executable model. And also, reactors don't expose their top-level code by default, so you do need to add an explicit export that you want to export the main function. Yeah, it's already built, so I can wasmer inspect what's going on. Wasmer inspect. Swift, yeah, build. And I call this reactor.wasm. You will see a few new things in the output here. Whereas commands have a start function, reactors have an initialize function. This one is quite important because you're required to call this once and only once, and before you call any other exports. So once you create or instantiate the module, you have to initialize it by calling this function. And after that, you're free to call any of the other exports as much as you want and in any order that you want. So we have the initialize function. We have our explicitly exported main function. We have a bunch of functions that are exported by JavaScript kit, and also a bunch of functions that are declared as imports for JavaScript kit. So JavaScript kit is partly implemented in Swift, part in JavaScript, and they interact through the imports and the exports. Then in the web app, I think there's not too much difference. We create a runtime. We also need to create the runtime for JavaScript kit. Again, it's part JavaScript. So we create a runtime. In the import object, we have to hook up both the imports for WASI Preview 1 and for JavaScript kit. Then don't forget, it's a reactor. You have to initialize it first before we do anything else. Then we also initialize the JavaScript kit runtime, and after that we're free to do whatever we want with the reactor. All the other exported functions are available through instance.exports with their exported name. For main, it's just the standard name there, but we can call instance.exports and .main just to call the top-level code in main.swift. So that's how you build a reactor. Of course, I'm not done yet, because what we just did here, exporting the main function, it's not exactly best practice. Usually you want to declare your own functions and just export your own functions to call over and over again, not the top-level code in main.swift. So the next example shows how you can export your own functions. Again, let's run it first, see what it does. Voila. This just plots a graph. The idea is here there's a timer running, and I think every 250 milliseconds it asks a Swift module for the next data point. And then it plots this data point on a canvas in JavaScript. That's the idea. It will just keep running forever and ever. So again, in Swift, we no longer have top-level code. We just have the single declaration, get the next data point after a previous point. And to export this from Swift to WebAssembly, we need two annotations. Probably you will forget one of them, which happened to me quite a lot. So you have to expose it to WebAssembly. This is new in Swift 6. Swift 5 required a lot of boilerplate code. So in Swift 6, we can just expose it as a WebAssembly function with this chosen name. But don't forget, you also have to add a cDecl just to indicate that you want to use the C calling convention. Otherwise, you get the Swift calling convention, which has different parameters, return values. So most likely not what you want. So if you export it this way, then in the web app, you can just call instance.exports.getNextDataPoint. So every function that you export with the proper annotations in Swift, you can just call it through instance.exports in JavaScript. Of course, I'm not done yet. I got a 10-minute warning, but I assume I can go a little bit over time because of the technical issues. So, of course, if you can export Swift functions to JavaScript, you can assume you can also do it other way around. So how can you import JavaScript stuff into Swift? I don't have to run this because functionally it's identical to the previous example with the same graph. It's just implemented slightly different. So we no longer have the get next data point. We have the plot next data point function, which is again exported using expose and cDecl. But this function depends on some stuff that comes from JavaScript. So we need to ask the graph, what was your current data point so I can calculate the next one? And can you plot something for me? So we have two dependencies at the current point and the plot function. We can declare these dependencies as imported functions with, again, two annotations. This time the same one twice. So we have extern wasm. You specify the module prefix, like we saw with the WASI underscore preview1 underscore, or the JavaScript underscore kit. In this case, I just called it graph. And then the name, plot, and current point. And again, don't forget also specify that you want to use the C calling convention. So if you declare these two as imports, then of course, in the web app, you will need to provide an implementation for them in the import object. So in the import object here, again, I hook up all the WASI functions, and then I add my own property, a graph. The name must match the model name that you picked. And I give an implementation for the current point function and for the plot function. I still have an exported plot next data point function that I can call here as instance.exports.plot next data point. So that shows how you can import and export functions both directions, Swift to JavaScript and other way around. Okay, but of course I'm not done yet. There's always one. Actually, I do have one more thing, but I didn't include it. But I did wanted to show this one just because it's a fun way to end the demo section. So don't worry, this is the last demo. It's also interactive, so if you have your laptop open, you can go to tinyurl.com/SwiftWasm. So tinyurl.com/SwiftWasm. Yeah, but you may already see it on your screen if you went to the website. This is just a simple, simple multiplayer game of Connect 4 implemented using Swift on WebAssembly. So I can just pick my name. We do need an even number of players, so I'm waiting for an opponent to join. So, Peter is playing against me. The game just always hooks up the next two players, so we do need an even number. So Peter, wherever you are, can you please make a move? Yeah. It's making it easy for me. Of course, I'm going in the middle. Okay, I'm not going to finish this game. I just want to show how it works. The idea behind this was I wanted to go back to the first example, using Carton and JavaScript kit, and I just wanted to push it as far as I could, just to see, can you actually build a whole web app purely in Swift? So I didn't have to write any JavaScript. I'm just writing pure Swift for all the game logic, and then JavaScript kit to do the UI. So I also wanted to see just how much Swift code can you reuse to build a web app. The idea was I wanted to build an iOS app and then just build a web version of the same app. I didn't have time to actually build an iOS app, but I started building one big shared library of Swift code that's completely platform independent, UI independent. So all of the game logic is in here. All of the multiplayer connectivity stuff without the actual WebSockets implementation is in here. So this one shared library powers both the front end and the back end. So we have a front end that uses JavaScript kit and the shared library to build the web front end. And we have a Vapor backend that also depends on the shared library that just uses WebSockets to synchronize all the different players. So this is a quite big example that shows that you can actually reuse a lot of Swift code if you architecture app in such a way that all your domain logic is in a proper shared library and independent from all the platform specific stuff. So that was my last demo. So hopefully I can easily get back to my slides, even if there's no presenter display. I don't care, let's just improvise. So while you're all playing Connect 4, I can just wrap up with some of the stuff I learned. First thing I learned from writing the Connect 4 example is to not do that. So please don't write your entire UI in JavaScript kit. Why not? Well, as I mentioned before, it relies heavily on a dynamic member lookup. So writing code with JavaScript kit is just like writing JavaScript. It's not any safer than writing JavaScript. And you don't have your IDE to help you, and you have added complexity because sometimes you have to convert between JS values and Swift values and so on. So what I do recommend is to do what GoodNotes did, is just try to reuse as much of your domain stuff in Swift as possible, and just use something like React or Vue or whatever to build a web UI on top of your shared Swift stuff. Second thing I quickly learned is that cross-compiling is not easy, especially setting up your development environment. So the advice I can give here is, if you're just doing this for the first time, like was the case for me, be very mindful about which toolchain am I using, which architecture am I compiling for, and which architecture is SourceKit LSP looking for. Because in the beginning I was always using Carton to compile for WebAssembly, but then I didn't have any auto-completion, and SourceKit kept complaining I cannot find foundation or whatever. Because of course SourceKit was looking for a build for my machine's native architecture. So it can be quite tricky, but fortunately we now have Swift SDKs. So Swift SDKs make cross-compiling a lot easier. If you want to try them out for the first time, I did add instructions to all of my demos on how you can use a Swift SDK provided by SwiftWasm instead of a complete SwiftWasm toolchain. So an SDK is much smaller to download than just having to always download a complete toolchain, which is gigabytes in size. Then another thing that you already saw in the demos is that the binaries can be quite large. So 60 megabytes was not unusual. If this is an issue for you, you should also look at the work being done on the embedded Swift mode, as this also applies to WebAssembly, and you can really shrink down your WebAssembly binaries to, I think, even below 1 megabyte, but don't quote me on that. People more knowledgeable are in the vicinity, so you can ask them. Okay, and then probably the biggest issue at the moment is that the WebAssembly version 1 is quite limited. Basically, everything is an int. There are floats, but I didn't see any floats, so everything I saw is just int. You can implement workarounds, like what JavaScript kit did, to deal with strings or other higher level types, but it involves passing around pointers to shared memory, which as a user is not something that you want to do. Having said that, I did do it, so I do have an example that the one more thing that I didn't show on how you can actually implement that workaround. You just take a look at the GitHub repository should you want to do that. But fortunately, WebAssembly version 2 is coming, and it comes with a component model that has built-in support for declaring higher level types. I think a bit like what Protobuf does. So things should be much, much easier in the future. So to conclude, I just want to say that I did enjoy using WebAssembly, despite that it's not that easy to get into. It has a lot of potential. I started out by focusing on web apps, but I learned there's a lot of other things that you can also do with WebAssembly. It's still early days for Swift support. It seems like it's always lagging a bit behind other languages, like Rust, for example. But it's getting there, and stuff like Goods Notes has shown that it can be production ready if you want it to. If it fits your use case, it may just be production ready. So definitely please check it out if you're interested in WebAssembly. And that's it. That's the end of my talk. So I'll just, if you want to, wait, I have to point the other way. If you want to try out all the demos, just scan the code on the left. And if you want to support all the stuff I do with education, because I made a decision to just publish everything for free. So if you want to offer some sort of financial support so we can really push things forward and hopefully grow the community with more and more students. I have 2 this year, but I'm hoping I can bring more in the future. Then just scan the code on the right.